Welcome back to Cloud 42. I'm James. For several years now, many of you have been telling me that I should install a DRO on my lathe. And for many years I've been agreeing with you. In fact, I've had a DRO kit for the lathe sitting in a box in the corner of my living room since 2017. What's been holding me up is I've not been able to come up with a good way to mount the X scale in the small amount of space that's available on my small lathe without severely limiting the size of the workpiece I can handle or the reach of the tailstock. I think I finally come up with a good plan, and since mounting a DRO on a small lathe in general and on the G0602 in particular is a question that comes up in the forums all the time, I'm going to go through it in detail. Let's get started. Let's talk for a minute about how we're going to mount the scale and the reed head on the X-axis. This is by far the most difficult part on a lathe this size because there just isn't really enough room to do it the way it's normally done, which would be to take the magnetic scale here and mount it vertically on the side of the cross slide, either on the right or on the left, and then mount the reed head horizontally facing into that. And on this lathe, there really isn't any room on the left, and on the right, we've got a very limited amount of space. If we were to take the scale and mount it vertically on the side of the cross slide, it would cover up the gib adjustment screws, so those would either have to be set permanently and recessed, or I would have to create a spacer and do something, but in any case it would require me to take the scale off to adjust those gib screws. So I opted instead to use something that I saw on one of Stan Zinkowski's lathes last time I was over at his shop. And what he did is he cross-drilled the scale. There's actually enough meat in the aluminum behind the magnetics to sneak an M3 screw edge on through the scale, and then that can be screwed into the side of the cross slide so that the scale moves with the cross slide. And then I'll mount the reed head underneath it facing up. Now all of the cutting action is going to happen over here on the, well, it's from the front of the lathe on the left, and so there's not really going to be a contamination issue here. We could put a shield over this if we have to, but I don't think it's going to be an issue. We just need to create a bracket that will allow us to mount that reed head and adjust it. Now because all of these are machined surfaces, and I'm going to create a machined surface on the side of the saddle here, you don't need any adjustment in the side-to-side direction to get this aligned. We just need vertical adjustment. So we've got slots in the bracket to do that. We've got a couple of holes up here to mount the reed head in there. We can set the thickness of this notch to match the thickness of the reed head, and we should be able to machine all this precisely and avoid a lot of the adjustment that's necessary with a traditional DRO install. The one other feature I added here is this screw, and this does not go into the saddle. It only goes into this bracket, and it provides a bump stop for the tailstock to bump up against. So I can adjust that screw in and out so that the tailstock will come up and hit that before it hits any of the parts of the DRO, hits the scale or any of these screw heads. So that will protect this and give us some measure of safety while using it. So I think that's it. We just need to tear the whole lathe down because I do want to machine a flat spot on the side of the saddle here, and we do need to do some machining on the cross slide, so this seems as good a time as any to completely take the lathe apart and clean it and make the modifications that we need in order to attach this. The first thing that needs to come off here is the compound, and on this lathe it's just held down with two clamping studs with nuts. Just loosen those. Rotate this out of the way and make it a little bit easier to get those off. Make that go away, get rid of the studs. And then I have a metal shield that covers the ways and protects them from debris and drop tools and drop chucks. Get that out of the way. That's where all the oil went. And we can take the cross slide screw out. The handle mechanism just unscrews from the front, and then we can turn it clockwise because it's a left-handed screw and extract that. And we should be ready to take the apron off. The apron's just held with these two screws on the sides, but there's actually some other stuff in the way. Is there a third screw in the middle? I remember seeing one in there, and yes there is, but it's for something else. Let's get the threading dial out of the way so that doesn't fall off and isn't in our way later. Then we can finish taking out these screws and get the apron off. Yeah, it was graceful. Now the apron actually has the half nut in it, which is attached to the lead screw, and I wasn't sure if I'd be able to get that off. It turns out, nope, it has to come off the end of the screw, so we need to take off the end mount here. On this lathe, there's just a nut, and then there's an oiled bushing in this little cast iron block. 2 screws take that off of the lathe bed, and then we should be able to get the apron off the end. You could also disassemble the half nut, but I really didn't want to mess with that. You can see the feed gears there and the half nut. Then we can take out the carriage lock, which is just a single screw into a little metal strip, and then there's a metal strip on the other side anchored with 2 screws, including the one we found down underneath the slide earlier, and that just captures the saddle so it can't lift up in the front. We might as well pull the cross slide off along with its shield and gib, being careful not to drop those on the floor. Hey, I didn't drop those on the floor. And then there's a strip under the back. I just loosened the screws and that allowed me to tip the saddle off. Set that out of the way. The ways on this lathe look really good. However, the oil is making the Band-Aid slide around on my hand, and that's annoying. It took me a while to figure out how to fixture the saddle on the mill for machining. I ultimately grabbed a couple of 246 blocks and set those on the mill table and then clamped those down with studs and T-nuts. Then I've got the saddle pressed up against that with the machine surfaces on the bottom against those blocks, and then I clamped it on with a couple of C-clamps, one here on the left and one over here on the right. Now I'm going to be machining up here near the top, and so there's always potential that it's going to flex and we're going to get a little gap. It's going to open up down in here and it's going to vibrate. And I couldn't really reach it with any of the clamps I had, so I took a 1-2-3 block. I clamped that to the saddle with a welding clamp and then took another C-clamp and held that to the 246 block. That should stop any motion or vibration in the fore and aft direction, and then we can machine these top surfaces without any drama. To make sure I had this set up straight, I just used a dial test indicator in my Edge Precision Indicol clone here, and I set it up so that I could read off the top surface and ran it back and forth and just tapped it around with my little Randy Richard knocker to get it so it was nice and level. And you can see that came in pretty close, and then readjusted it for the front and did exactly the same. And you can see that it's set up nice and parallel to the x-axis there. And since this is ultimately the direction that matters for the motion of the cross slide, that should be good enough alignment to mill the side of the saddle. And I'm just using a 10 thou copper shim to set my height so I know exactly where the edge of the cross slide is, and then lowering the knee to the right number so that I can get the correct offset and just go ahead and mill this surface. Now you can see this is the right height as I calculated it, but it is definitely not cleaning up. So either I messed up something in the math or there's some inconsistency in the casting or something. But at this point I just called an audible and decided, well, I'm just going to keep raising the knee until it cleans up. And once we figure out where that is, we'll take the new measurement and we'll adjust the model and make the other parts to match. Ended up, I had to take off an extra 20 thou over what I had planned, but in a setup like this, 20 thou is nothing. And going back to the model, it looks like I probably made another mistake someplace else that compensated, and so my original dimensions ended up working out just fine. Still not sure what happened, but you can see there's a little witness mark there, so we took pretty much the bare minimum we could and still get it to clean up. Now, to locate the holes that I need to drill and tap, I am just using an edge finder on the back of the saddle and the top of the flat of the dovetail, and then just using the DRO to drive to the correct location and put in the holes. These are tapped M6 for the mounting screws to hold the X mounting bracket to the side of the saddle. Now, this material drills really easily, but the back of the casting is irregular and it's a little bit interrupted. So I don't really want to power tap these. I'm a little bit concerned about breaking the tap. So we'll just go ahead and get it started square and then finish it by hand with a tap wrench, just so I can feel where it is in the hole and won't hit the bottom and snap off the tap. And then once those are tapped, we just need to come back and deburr those top edges a little bit with a little Noga rotary countersink. Blow out the dust, and this part is done. Next up is the apron. Similar to what we did with the saddle, we just need to mill some flats to mount a reed head bracket. I'm just running the same indicator across this. It's kind of a rough casting, but I'm just sort of tapping it into place so that the average reading end to end looks like it's pretty much straight. And then we'll just bring in a 1/2 inch end mill and machine some flats on the top, or rather the bottom, of the apron. Now there's no particular dimension we have to hit here because we can adjust the scale to whatever position the reed head ends up in. So all we're trying to do is just clean up a flat spot on the bottom that's level from side to side, so we have a consistent surface to screw the bracket to, so it'll be level without having to do any kind of angle adjustments. So I got one side cleaned up. I'll just drive around the outside of the part to avoid hitting my clamps and maintain that level and see where we are. And it turns out this casting's pretty even, so this cleaned up nice and neat right to the same level, and this will work just fine. Give us a nice even surface. We can make a little bridge that goes across there to hold the reed head, and it should be straight. Now we need a couple of holes, so we'll just locate off of the two sides and the front of the apron and just use the DRO once again to drive to the right location and put in our tapped holes. Now I did get smart here and start using the vacuum because this is gray cast iron and it makes a tremendous mess. And so if I can just capture all the chips right at the source with the vacuum, it makes my life a lot easier. And again, same drill. I don't want to power tap all the way to the bottom because I don't want to break the tap off in the casting, given that I only have one of these and I don't really want to replace it. We'll just go ahead and run the tap to the bottom by hand. That way we can feel it and there won't be any surprises or any drama. Just blow out the chips, once again capturing them with the vacuum, and use the Noga rotary countersink to clean up the top edges. And that's all we should have to do here. We can take it out of the clamps and take a look at what we've got. I was a little bit concerned about getting chips down into the mechanism. It looks like we captured most of them, but I'll just shake it out here and I'll wipe it down before it goes back on the machine. We're also going to need some tapped holes in the cross slide, and this has got these little oilers in the top that kind of stick up proud of the surface. So instead of just dropping it directly in the vise and risking either crushing those or having them be in the way, I'll just drop in a couple of 1, 2, 3 blocks, and that'll give us a space so we can clamp this securely without interfering with those little Gitz oilers that are in there. Get this clamped nice and secure. Come in with an edge finder, and we'll just use the edge finder on each end and use the half function in the DRO to find the center, and then we'll locate off of the top surface, and once again just use the DRO to drive to our hole locations and go ahead and put them in. These are going to be M3, so they're pretty small, and I'm over drilling them. I'm going a lot deeper than is really required just to make it a little bit easier when I tap. The M3 tap that I grabbed out of the toolbox is a spiral flute tap, and that will pull the chips up out of the hole. And between that and the fact that I drilled these a little deeper than they needed to be, I felt like it would be safe to power tap them. So I'm just going ahead and power tapping these in the mill just to save time and effort. Makes a nice straight hole, and if you can do it, and you can do it without breaking the tool, it's a good deal. Now we'll just use the Noga countersink again to clean up the edge. You should be noticing a pattern at this point. And of course, blow out the chips with a little compressed air. And that should be it for the machining on the side of the cross slide. As long as I've got the cross slide off of the lathe and over here at the mill, I'm going to go ahead and center up on the pivot here for the compound, and I'm going to put some extra threaded holes in the top for a project that I have in mind that will be coming up soon. I just don't want to take the machine apart again and bring it over here to the mill to do this, and I already know where I want the holes, so I'll just go ahead and put them in. I'm just going to drill 4 holes evenly spaced around the pivot for the compound. And I'm going to go ahead and run these all the way through the cross slide, all the way through out the bottom dovetail surface, just like the compound clamp the holes that are already there. And since these are going all the way through, it should be totally safe to power tap these. I'll use a spiral point tap intended for hard materials like this, and just let it push the chips through the hole and out the bottom. I'm just feeling underneath here to make sure that the tap really did come through, and then we'll back it out. Then just clean up those holes on the top there, and since these go all the way through, we'll flip it over and clean them up on the bottom. And there we have 4 nice clean threaded holes for whatever that project is. Stay tuned. To make the X reed head bracket, we'll start with a piece of 1018 cold finish steel. This is inch by inch and a half, and I will square it up and bring it down to dimension. Now, when I'm working with cold finish steel, because of the stresses that are built up in the surface by the rolling process, I generally try to take equal amounts off of each side so I don't end up with a banana. Though with the aspect ratio of this part, it's really not that big of an issue. You'll note that as I'm cleaning up the surfaces, I'm also coming around the outside so that the cutter is always cutting into the piece, and that helps to reduce the burrs that build up and requires less deburring. Still has to be deburred though, so I will deburr this and flip it over, and we'll take material off the other side and bring it down to the desired dimension. Just knock this down with my Randy Richard knocker, make sure the parallels are tight so we get good parallel surfaces. And then check it with a micrometer, and looks like I'm under by about 8/10. I will take that. Now I'll put it back in the mill and take it to the final thickness, and then side mill the ends of the part to bring it to length. Now we're looking for 2.765 on the length. Let's see how we did. Close enough. The first operations I'm going to do on this part are all with a 1/2 inch end mill, so I'm just going to leave the 1/2 inch collet in there and use a 1/2 inch edge finder to locate my coordinates. And then the first operation is going to be to put in the counter bore for the stop screw. I'm just using a 1/2 inch 2-flute carbide end mill from Lakeshore Carbide. I'll set the 0 by touching it to the part and set my depth stop on the quill, just using a 1/4 inch pin as a spacer. The depth really isn't that critical. Then we'll just spin this up and plunge it in. Now I've never plunged one of these end mills before, so I'm just kind of guessing on the speeds. That was vibrating a little bit. Let me slow it down slightly. And yeah, that's a lot better. As long as you don't let it rub, it runs pretty smooth. You got to keep some pressure on it and keep it cutting and making a chip, and it just goes right in. Nice and smooth and quiet. Now for the mounting slots, the counter bores on these aren't round, they're slots, so I'm just going to slot in from the edge. There really isn't enough room to leave a rounded end on this slot, so I'll just bring it all the way in. And once again, this 2-flute end mill is cutting beautifully. As long as I keep some pressure on it, keep it making a chip, it just goes in nice and smooth and quiet. Now that's all the milling operations, so I will lower the knee here, take out that end mill and put in the drill chuck. And I didn't have my hand on it. I didn't think it was going to fall till I tapped the drawbar, and that was a $50 mistake right there. Blew the tips off of that end mill. Yeah, that was an expensive mistake. Okay, we'll put the drill chuck in and continue. Guess we won't be using that end mill. We'll start with a 1/4 inch drill, and I want to just drill out the ends of these adjustment slots. Now they're M6 screws, but I'm using a 1/4 inch drill because I have a 1/4 inch end mill to cut the slots, and I want to just relieve the ends of the slots so that the end mill doesn't have to do all the work. So I'll drill both ends of both of these slots. And this isn't strictly necessary, but I find that it makes it a lot easier. Now I'll just switch to the tap size drill for M6 and go ahead and put in the threaded hole here for the tailstock stop. And since this is a through hole, we can go ahead and power tap it. I'm using a spiral point tap that should push the chips out the bottom of the hole. So it should be zero drama. Now, as long as we have the drill chuck in here before I switch back over to a collet, we'll go ahead and drill and tap the M4 holes for mounting the scale. Now, these don't have to go all the way through, but I am going to go ahead and drill them all the way through just to make the tapping operation a little safer. And I'll just power tap those M4. I happen to have a spiral flute tap that pulls the chips up out the top, and so this went nice and smooth. I think that's all the drilling operations, so now we can switch back to a collet to mill out the slots. To mill out the slots, I'm using a 1/4-inch 2-flute end mill, and the only one that I had is a high-speed steel end mill that is extra long, so this is particularly flexible and pretty likely to chatter, but I'll just take it nice and easy. I'm also doing this in several different steps. I don't want to try to take it all at once. I'm taking it about half the diameter of the end mill in depth each time. So for a 1/4-inch end mill, I'm taking about 1/8 of an inch at a time and just going back and forth and taking my time, making sure to push it hard enough that it's making a chip and not rubbing, but not so hard that I risk a lot of deflection or maybe snapping off the end mill. Once we get all the way to the bottom, I'll just make one more pass to make sure it's clean and then come over and do the other side the same way. Using a long end mill like this is really not recommended. If I had a shorter one, I would use it. I do have some shorter 4-flute end mills, but I was a little afraid that they would pack up trying to do a full depth slotting operation, so this is what I went with, and it worked. Now, because I used a 1/4-inch drill for a 1/4-inch slot, you can see the transition between the milled surface and the drilled surface, but no one will see that, it's fine. I've got a 1/2-inch roughing carbide end mill in the collet now, and we're going to come back and mill this part to its final shape. We've done all of the features that we can with it still rectangular. I think I'm going to try climb milling and see what that is like. And I can kind of feel a little bit of tugging through the hand wheel. I don't like that, so I'm going to switch to conventional milling. Let's just take about half the width of the cutter to the full depth and just take a cut across and see what happens. These corncob style roughing end mills cut very smoothly and can take a lot of material at once, and you can see they make a nice little chip. The chips do come off pretty hot though, and so I'm holding up a piece of paper here just to keep them from hitting me, because they're not very comfortable. But this thing's working like a champ, plowing out a ton of material a lot faster than I'd feel comfortable doing with a normal smooth-edged end mill. But it does leave kind of a rough surface, so we'll switch over to a conventional end mill to finish this up. I learned my lesson, so I'm going to put a rag underneath this to make sure I don't drop it, and what do you know, didn't fall out of the collet this time. We'll just switch back to a standard 1/2-inch 4-flute end mill and come back and clean up all of those surfaces. I think the conventional wisdom is that you should not try to clean up the sidewall and the bottom in the same cut, but this is a pretty rigid setup. It's a nice sharp end mill, and it's a pretty shallow cut, so I'm just going to go ahead and try it, and it looks like we're getting away with it. Now you can see it is throwing off these long, thin, needle-like chips, and those are sharp, by the way, and they will stick in your flesh. Ask me how I know. Now we'll check with a micrometer here and make sure we are at the right dimensions, and we are. So the last step here is going to be to turn this part upright and take some material off the end here to clear the saddle on the lathe. And I opted to just go ahead and continue using the 4-flute end mill here, and I kind of wish I hadn't, because these chips are a mess to clean up. They're very sharp and they stick into everything. And we'll just clean up the bottom of that shoulder, and this part should be done. This is the final shape. We just need to do some deburring, and to do that, I get to use my new favorite tool. This is an NSK hand grinder. This particular one is the Emax Evolution, and I've got an 1/8-inch tapered carbide burr in here. And I've got this running about 30,000 RPM. This grinder goes up to 40,000 RPM. And to say this thing is smooth is an understatement. The first time I ever had an experience with a grinder like this was at the Barzy Summer Bash this year, and Aaron from Always Sunny in the Shop put it in my hand, spun it up to 40,000 RPM, and it sold itself. I've used Dremels and other rotary tools, and they're generally loud and they vibrate, and after a while your hand starts to go numb, and oh my goodness, this thing is quiet and smooth. You know, they're not cheap, but if you've got the cash and you have an application for it, this thing is just a joy to use. And that's all the time I have to work on the project this week. I knew this was going to be a really involved project, but I also think it's worthwhile to take my time and do something like this well, because I'm going to be living with this DRO on this lathe for many years to come. Next week we'll pick up right where we left off. My notes say to tell you to subscribe to the channel, but you already know that it helps me when you do that. If you enjoyed this video, give it a thumbs up and leave me a comment. I'd like to know what you think. If you didn't enjoy this video, leave me a comment and let me know why you're still here. Thank you for watching.